Hi, welcome to Math Defined. I'm Susie, and today we're going to be looking at prime factorization and factor trees. From this video today, you can expect to learn the definition of what prime factorization is, see some examples of numbers written in prime factorization form, and learn how to use a factor tree to find the prime factorization of a number. So let's get started. Prime factorization, let's start by looking at the definition of what prime factorization is. So prime factorization is writing a composite number as the product of its prime factors. So before we dig a little bit deeper into that definition, let's review what a composite number is. A composite number has more than two factors. So here are some examples, and I want to focus in on the number 18. 18 is a composite number because, as you will see in a minute, 18 has more than two factors. So I can get 18 by doing 1 times 18, but I can also get it by doing 2 times 9 and 3 times 6. All of these numbers listed below are factors of 18. And as you can see, there are 6 factors of 18, which is more than 2. So 18 is a composite number. So when I go back and look at my definition again, it is saying that prime factorization is writing a composite number, such as 18, as the product of its prime factors. Now we find products by multiplying factors together. And what's special about prime factorization is that those factors, those numbers that we're multiplying together, have to be prime numbers. So let's look at some examples of numbers written in prime factorization form. So I'm going to start off with the number 6. 6 is a composite number because it has more than two factors. 2 times 3 is written in prime factorization form because both 2 is a prime number and so is 3. So the composite number of 6 written in prime factorization form would be 2 times 3. Now let's take a look at the number 12. The number 12 is a composite number because it has more than two factors, and it also has 3 prime factors. And if I multiply those 3 prime factors together, I will get 12. So the prime factors of 12 would be 2 times 2 times 3. So let's multiply those. 2 times 2 is 4, and 4 times 3 is 12. So again, this is the number 12 written in prime factorization form because the factors that I'm multiplying together are all prime numbers. Let's take a look at one more. 30. 30 also has 3 prime factors. It would be 2 times 3 times 5. And when I multiply those together, I will get 30. So 2 times 3 is 6, and 6 times 5 is 30. So now let's take a look at some non-examples of numbers, these same numbers, 6, 12, and 30, written in a way that is not in prime factorization form. So I'm going to look at the number 6, and I've written 1 times 6. This is not the prime factorization of 6 because remember, both of those factors have to be prime numbers, and a prime number is a whole number greater than 1 with only 2 factors, 1 in themselves. So the number 1 is not a prime number, and neither is 6. So this is not the prime factorization of 6. Let's go ahead and look at 12. If I write 12 as 3 times 4, this is not the prime factorization of 12 because yes, 3 is a prime factor, but 4 is not. One more, let's look at 30. If I write 30 as 5 times 6, this is not the prime factorization of 30 because yes, 5 is a prime factor, but 6 is not. So you might be thinking to yourself, well, how do you find those prime factors of the numbers? Well, in math, we can use a tool called a factor tree. And factor trees always remind me of pine trees because I put the composite number up at the top and I create a tree by making branches off of the composite numbers. So these are my little branches here, and I think to myself, well, what 2 factors would give me 12? And so I think, well, I can do 2 times 6. Now, the goal of a factor tree is to find all the prime numbers in the factor tree, and when we find them, we circle them. So I'm going to give you a little reference here at the bottom for the first 6 prime numbers, and as you can see, 2 is a prime number. So I'm going to go ahead and circle it. Now I look at the number 6. 6 is not a prime number, it's a composite number, so I'm going to give it 2 branches. And I can get 6 by doing 2 times 3. And I know that 2 is a prime number, so I circle it. And I know that 3 is a prime number, so I circle that. And now in my tree, all of the prime factors of 12 are circled in my tree, and that is the prime factorization of 12. So I can write that as 2 times 2 times 3. And you always want to double check, make sure you didn't forget one, by multiplying those prime factors from left to right to make sure you get that given number. So 2 times 2 is 4, and 4 times 3 is 12. All right, let's look at the number 18. Again, 18 is a composite number, so I'm going to give it 2 branches, and I can get the number 18 by doing 2 times 9. And again, I need to look at those prime numbers, and I see that 2 is a prime number, so I'm circling it. 9 is composite, so I'm going to give it 2 branches, and I can get 9 by doing 3 times 3. And I know that both of these 3's are prime numbers, so I'm going to circle them. So the prime factorization of 18 is going to be 2 times 3 times 3, all of those circled numbers in my factor tree. So I'm going to go ahead and check that. 2 times 3 is 6, and 6 times 3 is 18. Now my last example, I'm going to use 18 again, so I'm going to give the branches for the composite number. The reason I'm doing this one again is because I wanted to explain to you that in the beginning when I used for the first 18 2 times 9, what if you were a person who thought, well, yes, 2 times 9 is 18, but you were thinking 3 times 6. And you might be wondering, would that work if I used a different factor pair? Instead of 2 times 9, could I start with 3 times 6? And the answer to that is yes, you could use any factor pair that you want as long as it equals 18. And in the end, you will still end up with the same prime factors. So I'm going to show you. So 3 times 6, I know that 3 is a prime number, so I circle it. 6 is composite, so it gets 2 branches. And then I get 6 by doing 2 times 3. I'm going to circle those prime factors of 2 and 3. And if you compare the two factor trees, you can see that in both of them I have one prime factor of 2 circled, and I have a pair of 3 prime factors circled. So the prime factors of 18, the prime factorization of 18 is still going to be exactly the same. And I can double check that. 2 times 3 is 6, and 6 times 3 is 18. I think you're ready to try a few on your own. So I'm going to go ahead and start with looking at this number of 60. It is composite, so I'm going to give it 2 branches. Now 60, like the number 18, has many different factors. So in order for us to stay together on this video, I'm going to go ahead and start you on a factor pair of 2 times 30. A factor pair is just a pair of numbers that when you would multiply them together, you would get 60. So then don't forget, my goal is to look for those prime numbers, and I know that 2 is prime, so I'm going to circle it. 30 is composite, so I'm going to give it 2 branches. And again, 30 has a lot of different factors, so to keep us all together in the video, I'm going to give you the next factor pair of 3 times 10. And I know that 3 is prime, so I circled it. And from here, you can finish it on your own. So pause the video and finish it up. All right, so you would know that 10 is a composite number. And to get 10, I would use 2 times 5, and both of those are prime numbers. So the prime factorization of 60 would be those circled prime numbers, or 2 times 2 times 3 times 5. And you always want to double check, make sure you didn't leave one hanging in the tree. So 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. Good job. Let's try one more. Let's try 88. We know 88 is composite, so it gets 2 branches. And again, many different factors, so I'm going to go ahead and start you off with 11 times 8. And I know that 11 is prime, so I've circled it. And you go ahead, pause the video, and finish it up on your own. All right, you would know that 8 is a composite number, so it would get 2 branches, so I would do 2 times 4. 2 is prime, I would circle it. 4 is composite, I would give it 2 branches. I know I can get 4 by doing 2 times 2, both of which are prime. So the prime factors are circled in my factor tree. So the prime factorization of 88 is 2 times 2 times 2 times 11. Double checking, 2 times 2 is 4, 4 times 2 is 8, and 8 times 11 is 88. So good job with that. Let's wrap this up with a vocabulary review. So we had 3 important vocabulary words: prime factorization, So prime factorization is writing a composite number as the product of its prime factors. A prime number is a whole number greater than 1 with only 2 factors, 1 in itself. And a composite number has more than 2 factors. So I hope you found this video to be helpful. If you did, please click the like button at the bottom of your screen. And if you'd like to see more of my videos, go ahead and become a subscriber by clicking the subscribe button along with the notification bell. So thank you so much for watching, and I'll see you next time.